Thank you for invitation and thank you for the words about our company and me. I'm happy to be here. Last year in Portland was my first time to have a lecture in USA, and I've seen a lot of interest, and so Ken Levinson asked me in the springtime if I would have time to speak a little bit about projects, because we have a big variety of projects. We started with residential buildings, small ones, with general design, and then we took our experience to the larger projects where the complete teams were existing. They only had no knowledge about passive house, and so we invited the passive house standard to these teams. And in the last few years, there is now a new market in the non-residential building, and the non-residential building is more the field of a passive house than the residential, because for example, in an office building, you don't have to heat in the winter. There's enough internal gains, but you have to think about the cooling. And to cool it down with passive house standard, you need the passive house standard you need for winter quality. It's an advantage to have it for summer to reduce the cooling and to have this efficient quality management to reduce it by integrated design and to make better buildings. So the passive house is in any way the best standard you can do, and even in non-residential buildings. So I will show you a big variant. I only have 100 slides. So the architect from Belgium, he had 113, and he did it in the 60 minutes. I hope I will keep the 60 minutes. So maybe some slides I will do very fast, only to show you what's possible. Okay. Okay. We define passive house with the most sustainable building you can do. In Germany, there's a lot of politics now. They want to describe sustainability with a lot of technology, but less insulation. And it seems to be the architecture is the most important thing at the building, and the rest do it as usual, or fill it up with a high technology and a high energy demand for technology and control of a house. I think this is not the future. The future is to build houses very easy, very high quality in the substance of the building, and to bring a high comfort. And if we advertise passive house, we advertise it with comfort, not with economics. The economics you will have from the first day. It's the comfort, it's the building quality, it's the much better quality, longer lasting quality of a building. That's passive house. And it is economic anyway. If it's in 20 or 30 or 40 years, it will be economic in any way. And if we want to do something for climate change, we have to do it now, and we have to do it with passive house standards, not some house standards. So the building quality and the usability is also a problem. If you do non-residential buildings, you have to speak with the client what he wants to do with the building, to speak about the user profiles of the building. School in Germany is half day full. In USA, maybe the whole day. Office has a normal office times. A factory has maybe 2 or 3 shifts. So you have to speak what's now, what could be in the future, and then you have to think about the system. So non-residential is much more difficult to make the concept for the house, but it's easy to build and easy to maintain and to keep it quality. I was asked if we are only doing these large buildings. No, we started with the small ones, like Stas said, and we always do it now. We still do it because part of our company is engineer and technicians. They are doing the complete design, the complete structural design, the technical design for heat ventilation and MVHR. proposals and the project management, and the other part is using this knowledge of the overall planning in the large projects where the team is existing, but they have to learn to work together. And this we learned in the small houses, and we try to transport in the large houses. And if we have a client who wants to have the quality, he gets it. So integrated design, in the design and in the execution, this is the main thing, not to stop in the design and then to give it a company to build it. Even in the other parts, it has to be integrated to keep the level, to work on the same quality, and to install a quality management system. And the certification is a basement of a quality management system. It's not the quality management system because you have to think about fire protection, about sonic, about other building physics aspects without heat, humidity, but it's a big part of a quality management system. You only have to open it and to make it complete. This is our office team. These are some buildings we did. This is the largest passive house building worldwide in 2009. It was certified by the Passive House Institute, 354 units. This investor, Neue Heimat Tirol, a housing company who has 18,000 flats in possession. They built 2 years later this aerial, 450 units, the first Youth Olympics in Innsbruck 2012, where this was the Olympic village for them. So we have now 800 apartments, flats, passive house standard in Innsbruck within 5 years. And this company is now doing the 2,500 flats. So they decided 3 years ago only to do passive house, nothing else. Because it's logical to do it, not to go back, to go forward. And the architect of these both buildings, he won this competition and he was the second in this, and he made half of them. He won the competition in Vienna. This is the first prison worldwide, and this is the first courthouse worldwide, a 65 million project. The government of Austria never did passive house before. Austrians, yes, some architects in some parts of Austria, but the government never did a building before. And the architect said, let's make a team, let's convince the government that it's the most logical to do a prison and the courthouse in passive house standard. It was quite easy, because the old prison had 450 kilowatt hour a square meter a year, and the new one has 15. So there's factor 30 between. It's paid in 1 year, the overcost of the passive house. So it was more expensive, but it's not the problem. This is the most effective building Austria ever built, and it got a lot of prizes. We are doing the certification work worldwide. We did the first passive house certification in British Columbia as in Whistler. It's an Austrian-related guy, Dörfeld, who made this house for them himself. He is also the carpenter. This in Tirol is an office building. Now the kindergarten of the University of Aberdeen is in finishing. This is the first Latvian house I have in my slides. Very interesting, and this is a very complicated building in Munich now. It's coming up. The designer visited the CEF course and he finished it, and then he tried to begin to calculate, and then he went to us for question to have a calculator, and then we've seen it was too early for him to calculate a so complex building after the course without having experience before in smaller buildings. So we are supporting him a lot. So the certification is very close connected to a consulting to bring him up and to bring it to certification. The quality management system I'm speaking about is it's very common. It starts with quality planning. It's not quality assurance. It's the main thing. The most people speak about quality assurance. You have to design it first. You have to build a team that's skilled and that's convinced for Passive House, who wants to do the new thing, and not to sell the old ideas. To have an integrated design. Integrated design, the minimum is that you have a good communication system. And there is one report after a meeting and not 5 reports with different contents. To speak about the same thing, to have a project manager who wants to do it and is able to handle it fair for all partners. This is integrated design, and to bring it together very early and steady till the building is built. Specialized planning, detailing, workshops, very important to bring people in workshops together. You can mail thousands of MB, but it's not quality. To bring people together to speak about details, you have the best quality in the shortest time. It costs time, but the other thing costs more time and has less quality. And then, second, the quality control. If you do the tendering, you have to have the working plans complete, not 50%, and the rest is the builder's work. You have to have it complete and have to describe it the right way. If you want to have a special ventilation quality, then you have to describe it. And even you have to describe it it has to be in the standard of a Passive House aggregate. There are a lot of big ones, they are not certified. Some mid ones are certified, and the smaller ones, you have a lot of them. But in large houses, you often have the problem there. The ventilation systems you get, they are not certificated, but you should describe what you calculated in your PHPP, that you can check the contracting before the contracting is done, if the quality is in the offers, and to bring the quality of the design to the building site, to inform the craftsmen on the building site, to make a workshop. It's very exciting to do a workshop with people on the building site. If they see the designer in this role, not only with the hat and the office shoes on the building site, also to speak together, to work together. A workshop means to sit 2 or 3 hours together. The designers are explaining what the requirements of the buildings are and what special regard it has, and the working together is better. So I wrote communication, to bring a better, fairer communication to the building site, and you will have more quality. And then you can make the quality assurance. The quality assurance, blower door test, thermography, or whatever, cannot improve a building. It cannot only show what quality the planning and the craftsman work was. And if it was worse, you often cannot really improve it to Passive House. So the quality assurance is very important, but the first is the design, the control, and then to assure it. And the next, the large buildings, we have the experience, you need monitoring. The technology is so complicated, you should know how the building is working. So you have to have numbers about the heat, about the domestic hot water, about the electricity demand of the ventilation system, or the CO2 levels in the rooms, because they are often not in the level you designed it. This is also communication. Some people, they tell you stories, I did it, and then they didn't do it. So in the monitoring, you see what they did. And so you can improve the buildings, and you can improve it much more than you planned it, if you have a good concept and in the monitoring to try to optimize the building. And then this was the result of the Neue Heimat Tirol, this company who is doing now Passive House as standard. They brought the knowledge they got in the next project in the planning period. The same project manager who made this project to the end made the next project, not another start, another level. He had a higher level. For example, we had this first building in Tyrol, we had 500 hours consulting, advice time, meetings, 30 meetings, a lot with architects and with the team. The second project we had 50, 10% of it. Same project manager. We didn't have to discuss about things. He knew what we are knowing, and the team was built in this way, so it was very easy to make the second building passive house. And it's often the problem, the client wants to have a passive house, and he has a competition. And the best architects are winning the competition, but they often don't have any idea about passive house. We now did the passive house in Innsbruck with architects from Vienna, very good architects. You will see it in this presentation. They never did a passive house before, but now it's certified and it's a passive house. So you need someone in the team who can guide the team, the MVHR engineers, the architects and the other partners to the quality. And this is the consulting we are doing. This is an example from an actual project. This what I'm talking about with certification or consulting. If there is less knowledge in the team about passive house, or if you have done the passive house designer course and you are not secure in the details, but you want to do it right, take people into your team who are building physics, who are specialized in some kinds, or who are specialized on certification consulting, but take them early in the team. This detail we got about a building from the architect, and he calculated with PHPP that this building will be passive house, heat bridge is free. Here is a little insulation, here a little insulation, here is a lot insulation inside, here is concrete and here concrete. So this is not a heat bridge detail, even not a sustainable detail, because if the outside floor is here and here starts the wooden construction, there will be mold in a short time. So this has to be improved. And this was the detail we advised to do it in the prefab construction, to insulate it outside, and to do it nearly heat bridges free. So these people who are skilled should be involved in the team very, very early. As later they are in the team, more difficult is to keep it in passive house standard, or to do it with less time and less money. Also, the ventilation and technology system of the building. You should use checklists to go through before you start the PHPP. You know the architecture. You should know about the envelope, the thermal envelope of the building, about the heat bridges and the air tightness layer. And you should know, for especially, what the client's requirements are, what your user's requirements are. It's very different. You can have a building where the client tells you stories and the user will use it completely in another way than the client told it you. We had one. They said, we have 4 people in the office, 2 people in the office. This was the normal size, the same we have in the basics of the PHPP. And after 2 years, he had 4 to 5 people in the office, and he told us the ventilation system is not good enough. The client told us it's okay with 2. The user, he knew this time that he will have a very high density in the usage of the office. You have to speak with the user if the client is not using it, and you have to speak with him about the user profiles. It's very important for the overheating of non-residential buildings. If there are much more people in the office, if there is a higher heat load, you will have more problem with overheating and the cooling demand. Also the ventilation, not to go to the industry, which system you have, and then this way will get, and only to take the recovery quality, the 85 or 90% into your calculation, to think about, is it ventilated and heating separate, or do you heat with the air? It's very difficult, important to know it. If you do it central, one unit for the whole house or for the whole zone, or you do it semi-central, maybe each story one ventilation system, or you do it decentral, each flat or each room system. It's very important for the balance of the building and for the quality inside. If you want to add a humidity recovery, it's now the most modern thing to add a humidity recovery. It's okay, but the humidity recovery will lower your recovery by 10%. The newest results of the certified buildings recovery systems, you have 92-93% without, and 80-85% with humidity recovery. So you have to use it in the calculation. If you take the 92, you have to have the 92 and not 84. So it's important to speak with the client what he wants to do and not let him speak with the industry, and you have to make clear every point that's important for your quality and for the requirements of him. Then if there's a preheating system, if it's with air, with brine, or with electricity, if there's a shading, I will show you some buildings. The architects, they want to avoid the shading. It's possible in some parts, but not always. If you have no, it's a problem of design and to work together. If yes, which systems? In England, they told us we don't want these jalousies. They never work. So we had a big building company. They said we want to have a fixed shading or none. Which heating systems? The heating is not the problem in the passive house. You only have to do it efficient and not too big. The cooling, very important not in residential, but in non-residential buildings. It's very important to think about the cooling and which demand the client has. We now have a hotel. He wants to have some degrees more in winter, higher than the normal standard in passive houses, and some degrees lower. It's an American. I don't know why the Americans must have it colder in summer than the Germans, but this hotel has to be, so it's more energy to cool, it's more energy to heat up. It's in Germany. So cooling is very, very important because the most energy you use in non-residential buildings is for cooling and not for heating. And about the domestic hot water usage. We had one building, we designed it with low flow armatures for the shower with less water consumption. And the plumber said, oh, take this rain dance. It's perfect. It's like a waterfall in your shower. It's the normal has 5 to 7, and these rain dances, they have 25 to 30 liter a minute. So if you have a heat pump with a rain dance, you can forget it. You can forget the COP, because the heat pump will work 90% for the domestic hot water and not for the heating. So it's the wrong technology. So you have to have checklists to ask your client very important questions, and then you can start the PHPP. And not starting the PHPP, and somehow this will happen somehow by accident or not. So this sentence I wrote because I've seen this in England a lot. we did a tour around New York the last days. We've seen it in America also. It's very, very fast calculated, but not really thought about the main details to optimize them before you are calculating. So if you do it right in the team, there are a lot of teams, there are costs, maybe 10% more than the normal standard, and then the price is going higher and higher and higher. And then at some point the client will say, I cannot afford the passive house, forget it, we do a good efficient house but not a passive house. If you have the right team, you try to bring it down in the design time, and if you have a good interactive integral design team, you will bring it in an area maybe 50% below the price you thought it could be in maximum. So this is an example for we say 10%, and it costs in the end it costs 6% more than the normal building standard. And this is this chart, the chart of the evolution within 6-7 months of design. This is working together. This is integrated design. Some things are worse and some things are better. And there's more information, there's better the detail, there's more the working plans are fixed as better, as closer you can calculate in the PHPP. This building I showed last year, I only want to say some sentences. It's a medical center, very complicated, because a lot of users inside and a double glazing facade. This was a typical example where thermodynamic simulation was necessary to have answers for this special facade, and we changed the concept of the facade. It's now closed, and only there are shutters in the facade. So normally this double glazed facade is insulating, and only by humidity or special demands it's opening and it's ventilated. The architect wanted to have it always ventilated. And this you can show with a thermodynamic simulation how it works in the numbers. Also, these complicated buildings are very difficult to calculate the solar gains. They are necessary for the heat and also for the cooling. And with this solar simulation, you can do it better. You have the better informations for the calculations. But most of the clients don't want to invest in simulation programs. So you can do it with the PHPP. But in very complicated projects, and when we have the budget, we also use this simulation. And the basement is always PHPP, because the simulation has no certification. You have to believe the simulator. He can tell you everything. In PHPP, you have a clear standard. So the basis is always PHPP. And then we are separating the zones. We have in this building, we had 10 zones. There is a pharmacy. It has another usage than the store, and another usage than the rooms from the doctors. Yes. Oh, there's one missing. We are doing this multi-zone PHPP because you need one result in the end. You need one result for the whole building, and the result shows you in the whole house the same gains and the same losses. In the multi-zone, you divide it. If you have a zone with more internal gains and more sun because it's south and it is a north room, you have more information about the building, and the PHPP is able to show you much more than only an average. It can show you also very good information about zones, so you can avoid this thermodynamic simulation. But it's the minimum we are doing in multi-zone buildings with non-residential usage. Because you often have different ventilation systems, different usage, different target temperatures. We have one house with a swimming pool inside. There is the inside temperature is much higher than in the other rooms. Also the humidity. You have different orientations of the zones for the sun, especially in schools. You have different shading effects. Distribution and components are very different, so you can calculate it in zones and can give the client good information about special usage and special areas. This I showed last year also. It's the first museum worldwide. It's in a medieval town in the south of Germany. It won the Passivhaus Award last year. It won the German Architecture Prize last year. It won the European Prize for Integrated Design. Every 8 years it's this prize, and this year it was the finisher of the Mies van der Rohe Prize. It's the European Architectural Prize. So if you are in South Germany, try to visit it. It's a marvelous building done by the Stuttgart architect Lederer Ragnarsdottir Oy. Worth to visit it. Medieval town and perfect museum in efficiency and especially in the architecture. This is the next museum. It's the Museum of Bavarian History in Regensburg. It's also a medieval town, and it's at the Donau. It's 5 times bigger, larger. There's the Donau, and this is the medieval part behind. The architecture is not Passivhaus-like on the first view. A lot of glazing here, also in the roof. But if you have a big building, Passivhaus is not the problem. This building has a stone facade, and the facade should be also in the roof. I told the client, please don't tell people that Passivhaus standard is expensive. You don't know about the price of this facade. It will be horribly expensive, and if there are more costs, they will not be in the Passivhaus. It's the architecture. And then he's told me, that's right, because this was the reason we decided to do this building with this architect, because of the architecture. So, but I only wanted to say, it's a lot of people like to say the Passivhaus makes it expensive. The Passivhaus do not make buildings expensive. Also multi-zone, because they are very different in the usage. We had a foyer where the people are meeting. There are cruisers from the Donau, 300-400 people in one block coming into the museum and spreading into the museum. So it's very different. Use this museum, the showroom, exhibition, long-lasting exhibition, and then for special exhibitions, changing often, for the museum's school and shop, a restaurant, and the technique. The technology, the ventilation system is in the basement, it's in the warm shell, because there's a lot of heat. We don't want to have it in a cold cellar. We took it into the thermal shell, so there are no losses. You see the sections. It's not a very easy building in the constructions, and also some stories here. The basement, the first floor, the ground floor, the first floor, here a separated floor. The roof construction, very, very complicated. This is the foyer, this is the restaurant, this is the room for special use, this is the museum school and showroom. This is the second floor, the first floor with a constant exhibition, and this for the special exhibition. This is north and this is south. These are the building parts, very different building parts on the building. And this is one of the first things in the design. Where is the thermal shell? To define the thermal shell. This is the result in the energy demand. This is the heat. And this is the cooling of this building. I tell you why the cooling is so high, but this is 15 kilowatt hour square meter and kilowatt hour square meter a year, and this is the electricity demand. There are some missing. 1/3 of the electricity demand is the lighting. It's the lights, and not the lights on the ceilings. It's the lights for the exhibition parts. You cannot speak with these artists who are making the lights for the exhibition about efficiency. You cannot speak with them. So, no chance. So there's a lot of energy demand for electricity, so the heating is, you can forget it, this building. The heating, the building this in South Germany, the first museum, it's heated by the visitors. And this museum is also heated by the visitors. This is possible in passive house standard. And if it would not be a passive house, the cooling demand would be much higher. And the electricity demand would be the same or rather higher. So the passive house standard is the result of this chart. This was the ground basic work for the simulation, because the client wanted to know what's going on in the special rooms over the day. Because we had this rooftop glazings and large glazings in the facade. What's going on in this foyer in 365 days? He wanted to know it because he said he wants to have plus minus 1 degree in winter, plus minus 1 degree in summer, and 50% humidity plus minus 5%. This costs money to have these small variants. And in the special exhibition, he told us he wants to 4 degrees less and a little variance in the humidity, but plus minus 3. And this costs real money in the cooling. And this is a no-go. You cannot speak with people who are responsible for these projects to reduce these requirements. In the result, we've seen that because of special aspects, we have some days there is a less humidity than he wants to have. This is the time when the springtime changes to summer, and this is the time when the summer changes to autumn changes to winter. So he accepted this, that there will be some parts outside of the range he defined, but he wanted to know it. So this is a result of the dynamic simulation. This is a building we call Passive House 2.0. It shows what's possible in Passive House, that the 15 kilowatt hour is not the barrier. You can go under. You can go under to 4.9. This building has no shading. Okay, it has a shading. This is the south side. There's no shading in the living area. There will be a shading in the first floor, and in the second floor also a shading. But the rest of the house has no shading. And it works. It's an office building in the rest, and it works very good. The heating demand is 4.9 with normal insulation thickness in the roof and in the wall with normal windows, passive house, certified windows, glass. It's not a building with U values of 0.05. It's normal for our region, and if you have the right architecture for houses, you can do it lower than 15. It's not a problem. 10 kW heat power we need to heat it up. So it would have been these 5 heaters with 2 kW each would be enough to heat the whole house. We have 2 drills designed with 100 meter, and the company who delivered the drills and they thought they will have a good advertisement. They said, we never did a building like this with only 2. We normally have 8 to 10. We will give you 2 again for nothing. So he said, okay, we will take 2 more. He wouldn't need them. The square meters are 909, and the heating and domestic hot water cost of this building is €900 a year, not a month. And the production of energy is 40,000 with the PV panels on the roof. This shows that the PHPP calculation gave us the 10 kW, and the simulation also. You can see it's very close to. The special thing this is the air ventilation consultant of our company. He installed 8 different ventilation systems, semi-central. Each office and each flat is ventilated, but by an own ventilation system, and he had 8 different ventilation systems. So we have Sender, Powell, Erics, all the ventilation big companies on the market are in this house, and we can compare the numbers if it's right what they are having in their reports. Next, I think the future, I see it here in USA and more in Germany, the future of the passive house is the refurbishment, because 90% of the energy demand in the housing area is old houses and not the newer ones. We did one of the first 3 NY15 refurbishments with the Passive House Institute, and this is Munich. In Munich, a rather big building, a perfect architect. He got the money from the investor and told him, I want to have a house with a high value. And then first they wanted to make a sustainable certification, DNGB or whatever, you know it as LEED. And then when I heard that this NY15 is on the market, he said, oh, this is for me more sustainable than the others, because it saves energy and gives a high comfort. This building had 3 parts, a bigger one in the front, in the road area, with a cellar and a office, 2 offices, and then residential. The behind buildings all were residential. And we insulated them. The complete shell was developed with the architect, in which layer we can insulate, in which quality, and in the end we reached the goal, I think with 24 kilowatt hour a square meter a year. So below 25 we could make this building. This is the ventilation system. We gave advice to the energy, to the MVHR engineer, would be the best. So we have one for this house, and for the residential one, and for the non-residential part one. So it's a semi-central system. This is also is a nursing home, also refurbishment. I will show you it why there were balconies in the old building, and in the refurbishment we used every second wall, because the balconies were closed. There was a glazing outside now, and in every second wall we installed the ventilation system decentral. So it was the most efficient solution to ventilate these apartments, also with passive house standards. This is a school. It was finished 2013, passive house standard, done by the same architect. We did the museum. It's a PPP project, public-private partnership. Maybe you know it. And some weeks ago we won the next competition. here we have the numbers that the building is working in the numbers, in the consumption. We calculated in the certification. So you can see if you certify a house and you build it like the certification standards, you will. And there was a monitoring 1 year to bring it up, to improve it, the technology of this huge house. And after the first year, we had the level of the certification. This was the reason why the town of Nuremberg said this offer of our group was the most reliable for them. And so they gave us the job to make this new school in Nuremberg. It's a 50 million school. It's one of the largest schools in south of Germany in the last years. And Nuremberg only builds passive house standard with local projects. Central system in the sport areas and decentral in the classrooms and the teachers' rooms. Also, the multi-zone calculation, and you see a very. We have 14.4 in the pre-certification phase, and it's quite different in the phases. And some phases, like this is the technical room area, is a lot higher than the others. Oh, 3 minutes. This is a story of success. The first passive house hotel worldwide was built in my area. It's the Explorer Hotel in Oberstdorf. It's the very south part of Germany. And a year later, he built the second hotel, 70 rooms, the first. The second hotel, 100 rooms. The price for the 100 rooms was the same than the price for the 70, because they learned a lot. And now we are doing the number 5. The number 4 was finished some weeks ago in near Salzburg on the German border. The number 5 is now built up in Stubaital, that's near Innsbruck. The number 6 in Kitzbühel, maybe you know it, it's also Tyrol. And the number 7 to 10 will be finished till 2020. And he wants to make the 20 full till 2018. And the next 10 he wants to build in 2020. And there are a lot of communities, they want to have an Explorer hotel. It's a low-budget hotel, only for breakfast, and very sportive people. So this is a story of success. He decided to do passive house, and now it's logical for him not, to do passive house. Nothing else, nothing worse. This is the CO2 balance of the building, the emissions, and what it saves. And in comparison to older hotels and to the standard in Germany with the photovoltaics on the roof, it's a zero emission building. And in comparing to if it would not have the PV, it would be still 80% better than the building standard in Germany now. The result of this story of success is that this 5-star hotel, it's the only hotel in Austria with a beauty surgeon and clinic inside. He built his apartment house for the employees in passive house standard. He said it's logical. This will last more than 50 years, this house, and I will build the standard that's for the future, and that's logical for him, passive house. And he says the passive house is the standard for the hotels in the future, even with a 5-star hotel, because they have these swimming pools and these high temperature areas where the passive house is the best solution you can do. And the story is going on, coming soon. The Hilton by Hampton wants to buy a landscape in Frankfurt, and the town of Frankfurt only sells it if it's passive house. So they have to. They think they have a hotel in Berlin, and when they heard the numbers of this hotel, we calculated it, and this is 3 times better than the hotel in Berlin, and they thought this is the best you can do. So I think this will be the first passive hotel an American hotel investor has to do. Maybe it's the standard then, maybe, but this he has to do. This is the Lodenal in Innsbruck. So we started with a large project. With this project, it's still the best passive house in Austria. It was a 2 years monitoring by the University of Innsbruck, and it showed that in every numbers this house is the best. This is the Olympic Village. I show it the second time because this is area. We have 7 buildings concrete and polystyrene insulation outside, and we have 6 of them with a hybrid facade. It's concrete in the main construction, and the wall construction is prefab wood construction. The reason was time, and the reason was also they wanted to have these panels outside with the Olympic, with the text of the Olympics outside in 4 different languages. So it would be silly to screw through 40 centimeters insulation to try to bring the load into the concrete. So the wood construction, the timber construction was the most logical construction, and it was much faster to be built up. So this is the prison. They were asked, it's silly to put prisoner in a passive house prison. They don't want to leave. But the country saves a lot of money. It's logical to do. It won the state prize of architecture and sustainability last year. This is the 8th story we do in Ulm. Ulm is also a city. If you want to have landscape, you have to do it in passive house. If it would be in New York this way, it would not be a problem to get passive house standard to the standard. This is a special house for disabilities, people with disabilities. There's an inside pool. Passive house, no problem to do it. You have no problem. It's airtight, it's heat bridges free, it's perfect insulated. You can keep high temperatures in the building. It's very easy to do it in passive house. This is the nursing home in Innsbruck, the new one with the architects from Jena. It's built like a bridge. It's a passive house. It's built like a bridge because it's at the river line of the Inn, and it's a public area, and the competition was who can use this area and also save the countryside for the people who want to have a walk and who want to bike along the river. Also, a facade with panels, in this case aluminium panels. This is the multi-zone calculation. You see how complex the building is and what the quality of this building is in the architecture. This is also another facade, complete concrete. The first building we certified, it's complete concrete outside and inside, and in between it's insulated with polyurethane. So this company wants to start passive house with concrete buildings. A lot of architects want to have this concrete facade, so it's possible now. This I want to show, we didn't build it. We worked together with Sauerbruch-Hatten. It's a famous architectural office in Berlin. We made the second place in the competition, but the work was to work with a vertical facade and to work to give the architect an idea of the way he has to use the panels in the directions to avoid overheating, but also to have natural light into the house. And it also was planned as a media facade, so with LEDs, so they could write texts on this facade. Very interesting. And this is the last one of the facades. This is the latest one, the Federal Office of Health and Food in Bavaria. This architect wants also to avoid the shading, and these are glass panels. So he asked us how many glass panels, how could we use it to avoid additional shading. I don't know if we can avoid it on every side, but some orientations I think we can avoid it. Oh, this is the last one. The first Philharmonie orchestra building Passivhaus standard worldwide in Innsbruck. The town of Innsbruck builds it in Passivhaus standard. The standard is set. So also a vertical facade. Lot of glass behind and a vertical facade. So this is very difficult to solve, not in Passivhaus. Passivhaus is not the problem. To solve the overheating in this house and to keep the comfort in the summer especially. So to reach Passivhaus is a lot easier with large and compact buildings as the smaller ones. But we have the experience, because it's easier and there are liberties for the architects, they use the liberties. And so we often have U values of large buildings. They are similar to very small buildings, because we need this more insulation to give the architect the liberties. But you've seen it in the Passivhaus Award 2014. You don't really have a border for Passivhaus and good architecture. If you bring both things together, responsibility for a quite compact building, it's not expensive to do it in Passivhaus, and it's logical to do it. This is a building in London now we are doing. This is the Latvian building, also inside pool, and this was the reason the architects said, it's a friend of mine, do it in Passivhaus and you will not have a problem with this pool. If you would have done it with double glazing, it would have been a big problem. So Passivhaus solves problems, it does not make problems, it solves. This is the highest building in USA, maybe the highest in the world. It's in Crested Butte. We are now in the team to consult it. It's on 2,700 meters height. So this, I think it's too long. This is the new one information, maybe for people who don't know. The new PHPP 9.0 has higher heat gains for apartments, especially for smaller apartments. This was the problem. If you have a small apartment, you always have maybe the same fridge, maybe the same white goods inside, but less square meter. And so in the new PHPP, it's more efficient to calculate Passivhaus. So I would recommend you to use it. In the summary, Passivhaus needs straight weights to calculate. Not the fast and the cheap calculation in PHPP is the best. To create a building and then to calculate it. And then you know the results. And it's based on integrated experience in practice. So each SEF designer after training should do a certified house, and then he knows what to do. And if he does a refurbishment, even more to do it certified, to work with the 4 I's principle. It needs sustainable architecture, it needs convinced designer, craftsmen, better products, it needs a straight promotion. In the jungle of diverse arguments, we have it in Germany also. A lot of people want to keep the quality quite low, not Passivhaus standard, and to want to describe it somehow as sustainable. Straight promotion that Passivhaus is the standard you have to use, and to compare it with to add the certification to become the standard and not somehow. And Passivhaus is not cost neutral in the investment because the normal standards are lower. More quality cannot cost the same money. It has to be more expensive. but it's economic from the first day of using it, because you have more quality, you have more comfort, more building quality, less energy costs, and in the summary much more value. So it's affordable, and it's the most economic thing you can do. So that's the way we are doing in Germany, and we're doing more and more in the international projects. And I hope I could give you an impression what's possible in Passive House. And maybe it's starting up in USA to have more buildings, even the big ones, and even maybe the non-residential ones. There's a big market. Thank you.
Thank you, Dieter. Are there any questions? Yes. The question was, do you have any experience in Greece? Greece?
You mean in the Mediterranean area? No, the most south is Venice. We did near Venice, not direct at the coastline, but it's not difficult to do it with the new PHPP, where you have these different climate zones. It's not real difficult to do it. It's more the heat and less the cooling to solve the cooling, and less the heating and the humidity. But you can solve it very easy with the same Passive House components you have in the colder areas. Not a problem.
Yes, one more.
Why do you say that overheating is not an issue in Passive House?
Not an issue.
So the question was, why do you say that overheating is not an issue in a passive house? Why is not a problem? Why is overheating not a problem?
It's one of the main aspects of Passive House to avoid overheating. And you have to think about, and these non-residential buildings, you have to think about more about the overheating and the cooling than about the heating, because the heating it's easy.
But you had an example with a pool on the side of the house, and you said that's an area of heating load, but it's not an issue of Passive House. One of the last slides.
In the swimming pool, where
Yes.
you had the swimming pool, and you were saying that if you had double glazing, it would be more of a problem.
Yeah, in a normal house, you would not have had a ventilation system first. Then also you would have lower temperatures on the glass surface. You would have not the tightness, and. So if you have Passive House, you're doing right. It's not a problem.
All right, I think that's it. All right, thank you very much.